All right, guys, so we are still on quadratics and we are following through from what we did yesterday. So today really is just about practicing questions, and through practicing of the questions, we will get a much better understanding of the topic. All right, I just want to let you know that in this program, we really and truly only practice. We practice really and truly no level lower than exam level. We tend to use the past papers primarily, and sometimes, as I said, we would go and do questions that are a little bit higher than the level of CSEC, just to make the CSEC questions appear a lot easier. But for the most part, when we practice, we are practicing using past papers. All right. So the point is, if you can understand and do the past paper questions in class, then you can do them in the actual exam as well. And that is the approach and the mentality that I want us to have. If you can do it in the classroom on a normal day, then you can do it in the exam room on the exam day. And so, by doing the past paper questions, we are really building confidence. All right. And what I might do is just show you one or two actual exam paper questions on this topic. And what you might find is that they are a little bit easier than what I'm asking you to do. Sometimes they go to the full range, sometimes they go less. So a question might, for example, on an exam paper, might have 3 parts, but for the most part, we tend to do the questions right through to the end. All right. So if you look at the screen, where we see homework, I'm just gonna start there. All right, I'm just gonna start there. I know there was one more question that we wanted to do yesterday. Where is it? Let's see. Gone too far back. Went too far back. In terms of the examples. Went too far back. Right. So these are the examples we're doing. I did the first one there, and I promised to do the third one, but I'm gonna just skip to the homework. All right. There's something that I want you to take note of. Let's look at it. I want you to take note of this page. I want us to screenshot this page and use it as a revision document. All right, screenshot this page. This basically summarizes what we've been doing. It sort of summarizes the critical information. Here we are saying all right, so I'm going to come off camera now because I want to focus on the maths, right? I don't want people to be watching me. So I'm going to come off camera now. All right. Okay. Give me 1 second. Turn off the light. All right, guys. So what you're seeing on the screen is almost like a summary of what we've been doing, right? So far, which is to move from the standard form to the vertex form by the process of completing the square. One second. All right, so this is a homework page. All right, so what we said is that if we have this standard form, we can get to this vertex form over here by the process of completing the square. And the method that we are using to complete the square, now this is a function, right? And this f of x here could easily have been just a y, for example. All right? One sec, somebody said something about the login. Let's see. Okay. All right, sorry about that. Right. So could have easily been just y you know, or g of x or h of x, it doesn't matter. It's the same concept, right? So we want to convert from this standard form to this vertex form by the process of computing a square, right? And there are multiple methods to do it, but we are focusing on a formula method where we calculate the xt value here using this formula. We calculate this yt value with this formula. And once we calculate those two values, then we would have converted from the standard form here to the vertex form here. And when we go to the vertex form, the xt and the yt are the coordinates of the turning point on the function. And then we get down to here now. So if the a is positive, then the graph will have a smile shape as shown here in this graph. Smile shape. So we have said so far. When it has this smile shape, it then has a minimum value. And it is the f of x or the y that has a minimum value. And that minimum value is the y value down here at the minimum point. So this point is the minimum point. And we get to that minimum value when the x value is equal to the x value at the turning point. And that's what this statement is saying. That f of x, the function, has a minimum value of yt, the yt that we calculated here, which occurs when the x value is xt. That's what that is saying. And this is what CSEC asks you for a lot of the time. What is the minimum value of the function? And what is the value of x for which the function is minimum? And that is when the a is positive, it will be minimum. Sometimes they will say state whether the function has a maximum or minimum. So if you want to state whether the function has a maximum or minimum, you have to look at the a value. If the a is positive, you know that it's going to smile and have a minimum value. But if the a is negative, as here, then it's going to frown and then it will have a maximum value. And the maximum value, when the a is negative and the graph frowns, the maximum value is still the yt value that we calculate using this same formula. And that maximum occurs when x equals the same xt value that we calculate from here. I'm just summarizing what we did yesterday. And so if they ask for the coordinates of the minimum point, then you have to write it like this. As coordinates with two values, an x value and a y value. The coordinates of the minimum point, which is this point down here, is that xt and the yt value. It's coordinates of a point, an x value and a y value. If they ask for the minimum value, then it is just the yt value alone. If they ask for the value of x, where the function is minimum, then it's xt value. All right, xt value is that value. Then I might also ask,
again, please.
If I ask you for the value of x for which the function is minimum, they are talking about this xt value, the x value at the turning point. That's what they're asking you for. Remember, this is your minimum value. You know? This yt value is a minimum. Over here, the yt value is a maximum. And the function has this maximum value when the x value is this, the xt value. So I like to say the xt value and the yt value go together because they are coordinates of the vertex. They are coordinates of the vertex. Here we have a minimum vertex. Here we have a maximum vertex. So this page is like a summary of what you need to know and do, this page. So it's good to screenshot this page and sort of, just study it and look at it and, make it stick. And remember, you have to memorize and these two formulas based on the method that we use. All right. I remember we're choosing the A, the B, and the C, as we did in the first session yesterday. We have to consider the positive and the negative sign. We cannot ignore the signs. All right. Cannot ignore the signs. All right. So what we need to do now is put all of this into action. All right. We're going to put it into action now by doing the work. So this basically is a summary of the steps that we have to follow right? These are the things that they normally ask you to do. Sketch a graph, state the coordinates of the state the coordinates and nature. Now, this word nature, the nature is whether it's a maximum or a minimum. That's what I mean by the nature of the stationary point or the turning point. Turning point is either a maximum turning point if the A is negative, or it's a minimum turning point when the A is positive. So when you see the word nature of the turning point, it's talking about whether it's a maximum or the minimum. That's what the word nature means. All right? They might ask for the coordinates of the y-axis intercept, or they might ask for the axis of, yes?
So you can say the part with the name of the nature of the turning point for the minimum and maximum again, please, sir.
Yeah, man. When they ask you for the nature, the word nature of the turning point is simply referring to whether the turning point is a maximum or a minimum. That is all. So the nature of the turning point, the nature is either it's a maximum turning point or a minimum turning point. It's a maximum, it's a minimum turning point if the A is greater than 0, meaning if the A is positive. And it's a maximum turning point if the A is less than 0. That is if the A is negative. Remember, when the A is negative, they say the graph feels sad and so it frowns. And when it frowns, it then has a maximum point. When the A is positive, then say the graph feels nice, feel positive, and so then say the graph smile. That's just an easy way to remember it. When it smiles, it's going to have a minimum, a lowest point, a minimum point. So the nature is referring to whether the turning point is a maximum or a minimum. That's what the word nature means, the nature. Understand that? Good
Yes.
with that? All right, good. So these are typically the things that they ask you. And these are the things sometimes they need to do to sketch a graph. And that you have to indicate those things on a graph. All right, so I'm gonna skip over these and I'm gonna go to the homework. Because I mean, these are the same thing as function, you're doing the same thing with all of them. Just the values that are different, but you're actually doing the same thing with all of them, really. All right. Sometimes they'll ask you a lot of things. Sometimes they ask you a few things. Don't just be answering questions. Don't just be answering what you want. Answer what they ask you. So if they ask for the coordinates of the state of the turning point, if they ask for the coordinates of the turning point, you have to put brackets. You have to put the brackets and put the xt value and the yt value. Put the two values there. They ask for coordinates. They ask for the maximum value or the minimum value, then they really ask for the yt value. They ask for the value of x for which a function is maximum or minimum, then they really ask for that value of x is the xt value. So you have to calculate these values. That's why the method that we use in this class is to calculate those values. Because the part A, the part 2, and the part 3 of these questions really always about the xt value or the yt value. Always something to do with them. Always something to do with those values. And that's why we tend to do it this way. So you have those values explicitly in front of you. You know, the t means turning point. So xt means x value at the turning point. Yt means y value at the turning point. Turning point is either a maximum or a minimum depending on the value of a. If the a is positive, then it's a minimum. If the a is negative, then turning point is a maximum. All right, so that's why I say look back at that page, screenshot the page, and the information is there. You have to get it in your head. I don't have to go in the exam to be trying to figure out these things when you can just know it. So that you can just know it. There are some things in the exam you have to figure out. More things you go in the exam with that more things you go into the exam room with that you just know. Like when you know your name, you know your address. The more things you know, easier the exam is, because you don't have to waste time figuring out stuff if you know. So all the things that you can just know them. And for that purpose, I'm going to later on give you what I call a must-know sheet, a list of things that you should be armed with Like, just have them readily at hand in your brain, ready. You just know those things. You don't want to waste time figuring out those stuff in exam, because these are the things that they ask all the time. So all the things that they ask all the time. You just take time to just know them. Just know them. All right, just know them. All right, let's continue. So I'm going to work this question. All right, I'm going to work this question. All right, so let me just slide this over a little bit. I'm going to work this question first now. Let me put a blank screen and do it. All right, let's do it here. All right, so look at the question. So they gave us over here, these are past paper questions, right? They gave us these two functions. Part one, as a smile, because the A is positive, so it's a smile. And they give us this one, second one, that's a frown, because the A is negative. It's -3 right here. So this is an example, one with a smile and one with a frown. And with each of them, they want us to do all of these things. Each of them. They want us to complete the square, meaning to write it in the vertex form, which is A into x plus h squared plus k. That's what you see in most books. But we are using A into x minus xt squared plus yt. This is what we are using, because we understand what that is, and we understand what that is. I would have to try to remember and figure out what the h and the k is. And also, as I said, they change how they present this in the exam all the time. They keep changing it all the time. So we're going to stick to this one standard thing, regardless of what they give us up here. That's what they mean by completing the square. To write it in this format is to complete the square. Now, after we complete the square, remember, completing the square really is assisting us to find where the turning point is. That's what it is. All right. And so that's why the second part is asking us to state or find coordinates and the nature of the turning point. Nature means, as I said, maximum or minimum. So it's asking us for the coordinates of the stationary points. All right. And then of the turning point. Sometimes I say stationary point because that's a term that we use at a higher level. Okay. Stationary point, turning point is the same thing. All right. And then down here now, it's asking us for the coordinates of the y-axis intercept. You know that this really is just a C value. But because it said coordinates, you have to put it in bracket, and then you therefore have to put 0C, because it says coordinates. The coordinates, you have to give both of them. The x value at the y-axis intercept is 0. So it's always 0C. And then here now, they're asking for the equation of the axis of symmetry. Right? The equation of the axis of symmetry is always x equals whatever the xt value is. That's the equation. And then they're asking us for the maximum or minimum. Remember, this one will have a minimum, and this one will have a maximum. It's not gonna have both. A quadratic has either a maximum or a minimum. It's a cubic can have both. A cubic can have a maximum and a minimum. But a quadratic has only one. Either it has a maximum or a minimum. All right? So that's what this is asking us for now, whether it's maximum or minimum. State the value. Get the value of it. State the value of that maximum or minimum. See? The maximum or minimum value. That's what we want. And then now, we must take the value of x at which the function is maximum or minimum. And that value is xt. So the minimum or maximum value really is just yt. And the value of x we're talking about always is just xt. That's why this topic is so easy, you know. Always xt. And then having done that, this question is asking us to sketch the graph. So we want to do all of these things. This function first, and then with this function next. This one is going to be a smile, because A is positive. This one is going to be a frown, because A is negative. They mostly give smiles in the exam. If they said 20 of these questions or 10 of these questions, maybe 8 of them are smiles. Most of them are smiles. And that's why sometimes when they set the frown, because people are so used to getting the smile function, sometimes even when they get a frown, because they're so familiar with doing the smile, sometimes they still make the mistake and draw a smile when it's supposed to be a frown. Because I don't set the frown very often. We still have to get comfortable with doing the frowns. Because we don't know what's coming on the exam paper. So we're preparing for smile, we're preparing for frown. And some people, they don't set any of these questions at all, but we don't know what's coming on the exam. So we have to prepare for everything. All right, so let's go. So far, so good, guys. Everybody good so far? So that little discussion.
Yes, sir. Yes.
Right, that little talk was just to kind of, track back what we did yesterday. All right, that's what we're doing. All right, so we're gonna do the first part now, which is that function there. So we're gonna do the y function, part one we're doing, where we have y equals 2x squared minus 4x plus 1. We'll compute in the square for that function. Let's write this better. All right. When we compute the square, more than like the exam paper, we'll say a into x plus h squared plus k. But we don't care about that. Right? We are still gonna write y equals a into x minus xt squared plus yt. That's what we're going to use. So we're going to go from this to that. That's writing it in a different form, going from a standard form to the vertex form by the method of completing the square. All right? By the method of completing the square. Okay. So to calculate the xt value here, it's a formula that we're using. The xt that we want is minus b divided by 2a. That's a formula method that we're using. So what is a and what is b in this formula? A and b are taken from the standard form. They're taken from the standard form up here. There are coefficients in the standard form. The a is the coefficient of the x squared term. So it is this value. That's the a. So the a equals 2. The b is the coefficient of the x. That's negative 4. The number from the x. Negative 4. That's given the letter b. So b is negative 4. Note I did not say 4. I said negative 4. So the b is negative 4. And the c is a constant term. It's a positive 1. But don't put positive in front of a number when it is positive. So we're just going to write 1. So the c equals 1. All right? So those are the coordinates that we're going to use to calculate the xt and the yt. So we're doing the xt first. So we substitute the values, and we're careful with substituting the values. We must have what we call negative antenna. Be careful with these negatives. So this is negative b, and the b itself is negative 4. So this becomes minus, that is this minus I put down first, and then I have to put down the b now. But the b is actually negative 4. So I'm going to put down negative 4 for the b. I can put it in a bracket, or I can leave it outside the bracket. All right, so let me take this off and take this off. So it's minus a negative 4. And then I'm dividing that by 2a, 2 times the a value. 2 times the a value. The a value is 2. So it's 2 times 2. So this question we're using easy values, right? Make it easy. We're using some simple values right now for these examples. Right? And then this works out to minus here gives us a plus 4 divided by 2 times 2 on here is 4. So 4 times 4. 4 divided by 4 is 1. So this one is coming right here for the xt. Right there. That one is going there for the xt. We don't need to calculate the yt value. So I'm going to calculate the yt value. So I can say yt formula is 4ac minus b squared divided by 4a. So just substitute these a, b, and c values in this formula now. Substitute them in there carefully. All right, so let's go. So it becomes 4 times the a value. The a value is 2. So it's 4 times 2. Times the c value. C value is 1. I'll put 1 there in a bracket. Minus. This minus is this minus. Then I have to square the b. I have to square the b. B squared. But the b is negative 4. So I'm squaring negative 4. Negative 4 squared. and then I'm dividing by 4 times A under here. 4 times the A value. The A value again is a 2. So I'm dividing by 4 times 2. So far, so good. We'll move on. Very good so far.
Yes, sir.
Beautiful.
Yes, sir.
All right. So we'll continue. So okay, the YT then is equal to, I want to simplify now. 4 times 2 is 8 times 1 is still 8. So get the 8 up here. Minus, because this minus is not squaring, you know. That minus is not squaring, this one. It's not squaring. So it's going to come back as a minus right there. It doesn't become a positive. We are only squaring this thing right here. So that becomes a positive 16. So negative 4 squared means negative 4 times negative 4. That becomes a 16 right here. So all of this thing is this 16 right there. All right, I'm going slowly with this one so we can get it. Divided by this 4 times 2 you know is 8. So far so good? Using
Yes, sir.
easy numbers.
Yes, sir.
Using easy numbers so we can get it, all right? So this works out to the 8 minus 16 is negative 8 divided by 8. So negative 8 divided by 8 now is negative 1. So the YT value is negative 1. So this negative 1 is coming to replace this plus YT there. Because this YT that is here, I can put a plus in front of it if I want. Right? So the plus YT is negative 1. So I'm going to replace that plus YT with negative 1. All right? But usually, as I said, when you put down something that is positive, you don't put the plus in front. It's understood. All right? So now that I have the XT value and the YT value, and I also know the A value, I can now write the vertex form. This is a vertex form. And let's write it now. Right? So I can say, therefore, my Y is equal to the A value first, which is 2, bracket X minus it. I put on my X minus first. And I'm going to put the XT value now, which is 1. 1. Close the bracket. And people always forget to put on the square. Don't forget to put on the square. And then as I said, this plus YT is negative 1. So plus YT, I'm going to put negative 1 there for the plus YT. And this is it. This is, let me put a different color. This is the answer for the first part. This is the answer for part A. Any question? All right. No, well, actually, I complete the square. Hold on a second, guys. Hold on a second. Somebody call me out. I'm pause the video. Just give me 1 sec. All right, guys, sorry about that. All right, so that's not actually the answer for A. No, complete the square. But now that we complete the square, we can answer part A. Right? The question said, using the method of completing the square, use the method of completing the square. So we had to complete the square. This is using the method of completing the square. That's what we did here. Now that we complete the square, we can start answering these questions down here. All right, we can start answering those questions down here. Let's go and answer the question. Let me answer them in red. Let me answer them in red. All right. So the first answer is on that is for us to state the coordinates of the coordinates and nature of the turning point. The coordinates and nature of the turning point. Now the coordinate is XT, YT. I'm just writing them down. That's the coordinates. This is the coordinates. We have to put the value. So the XT value is 1 and the YT value is negative 1. All right, that's about the coordinates. All right, coordinates. Then we'll come to the nature. It's asking us for the nature. How do we determine the nature? We can say since the A, which is equal to 2, is actually greater than 0, I could say it is positive that implies that the turning point is minimum, right? Because when it is positive, the graph will feel nice and smile. And when it smiles, it has a minimum. So we can say, since it is positive, we have a minimum turning point. So this is a minimum turning point. I'm going to write it beside it. Minimum. It's a minimum turning point. The one negative one is a minimum turning point. X, T, Y, T. So far, so good? So far, so good?
Yes, sir.
Bino is asking us for the y-axis intercept. Remember, the y-axis intercept corresponds to your C value, right? So see, you know, the y-axis intercept. That's the point where the graph intersects the y-axis. On the y-axis, the x value, let me go in details now. Why it is the C value, right? Let me see why it is the C value. I'll get it from the C. We know it's a C value now, but if you don't know why it is a C value, let's look at it. Now, on the y-axis, points on the y-axis, the x value is equal to 0. On the y-axis, x value is equal to 0. Now, remember, the function is actually y equals 2x squared minus 4x plus 1. That's a standard form. This is a C value. Now, if you put the 0 here for this x and here for the x, then them two you're going to work out to 0, and you're going to be left with that y is equal to 1. So at the point on the y-axis intercept, the x value is 0 and the y value is 1. So that's why the point is 0, 1. Right? 0, 1. So the point on the y-axis where x is equal to 0, these two parts work out to be equal to 0, and y then becomes 1, which is C value. But we just simply say that the y-axis intercept, just for simplicity, is a point 0, C. This is a C value. This is the x value there, and the C value is the 1. And we can see why it is 1. Why the answer is a C value, which is 1. We can see it. So it's a point 0, C, which then is 0, 1. So this is the answer for the y-axis intercept. This right here, 0, 1. So you can just write it down, but I just want you to understand why it is 0, 1. Think you understand why it is 0, 1, guys?
Yes, sir.
On the y-axis.
I have a question, sir. Will they be asking us to like show the reason why it is 0, 1, sir? Or
no, the question is just like this. The question is as shown on the screen. So just write it down. Most time the question will say write down. So just write it down. So you don't have to go into expert. I just want you to understand it. The next time I'm doing one of these questions, I'll just write it down. I'll just write it down. I won't bother go into why it is that and why it is that. Because I'm teaching the thing now, and I want you to understand why it is that. I don't just want you to know it. I want you to also understand it. That's why I'm explaining it. Why it is 0, 1. Why it is the 0 C value. Because the x value on the y-axis is 0. All right? So far, so good? So far, so good?
yes, sir. Yes, sir.
Come to part C now, which is asking us for the axis of symmetry. The axis of symmetry is a vertical line that passes through the turning point. So it's like the graph is like this, it smiles. It is totally symmetrical about a line that divides the graph equally. And it passes through this point. Now, when we learn coordinate geometry, or the topic of coordinate geometry, we will learn that vertical lines carry an equation, x equals a number. That's the equation of any vertical line, x equals a number. And the number is the x value at the point that it passes through. So since it passes through the point where the x value is 1 and the y value is -1, it is x equals this x value. is the equation of that line. Because all points on this vertical line, the x value will be 1. That's why the equation of that vertical line is x equals 1. Happens to be the axis of symmetry. So the axis of symmetry is x equals the xt value, which is the value right here. Right? So then I'm going to explain it and all of that. We're just going to write it down. Right? So the axis of symmetry in part 3 is x equals whatever the xt value is. That is, i.e., what is that really? That really is x equals 1. Because the xt value we calculated up here, which is 1. See there? That's what we did first. It's x equals 1. The equation of axis of symmetry is x equals 1. So this is the answer right here for that part. X equals 1. Part C. Then part D now. Part D now is asking something that they like to ask in CSEC. They said they want us to find the maximum or minimum value. We know it's a minimum. Maximum or minimum. They're not telling you which one it is, so that's why I ask a question like that. They say find the maximum or minimum. Which one is it? It is minimum. Find the maximum or minimum value of the function. Remember, the function is a y function, right? The function is a y function, right? Because the y values is what you get out of the function. Y values. By putting x values inside here, you get y values out. So the function is referring to y. The minimum value of y function is y. The minimum value of y is the yt value, the lowest value on the graph, which is the yt value. So we know it's a minimum. And they ask us for the value of x for which it is minimum. That value of x when it is minimum is the xt value. And I can show you by calculation here. Let's just diagnose a little bit and show you. Right? Now remember, let me show you. Let's diagnose a little bit. Remember that the function is y equals 2x squared minus 4x plus 1. And I'm saying that the y is equal to -1 when the x is equal to 1. And I can prove that. Remember, this is the xt value, and this is the yt value, I can plug this one in the formula here and here. And the y value coming out there is going to be that, -1. Let's do it. Right? Prove that the minimum value is -1 when the x is 1. So when the x is equal to 1, let's work it out. When the x is equal to 1, which is the xt value, talking about the xt value. When the x value is equal to the xt value of 1, the y becomes 2 times 1 squared minus 4 times 1 plus 1. Remember, I'm just doing this to prove it. You don't need to do this in a solution. I'm just doing it to prove it this one time. I'm not going to do it again after this. It's just to prove that what I'm saying is true. That when the x value is equal to the xt value, the y value works out to be the yt value. See it here, let's work it out. Y equals, this 1 squared is 1. So this is like 2 times 1, which is 2. So all of this works out to be 2. This is minus 4 times 3, 4 times 1, sorry. So it's -4 that. And then this plus 1 comes back, plus 1. You see it? So this is 2 minus 4 is -2 plus 1. -2 plus 1 is -1. So the answer here is -1. This works out to -1. Which this is really not the yt value. See? So the minimum value is -1, which is a yt value. So this is the minimum value, which occurs when you use the xt value of 1, when you use this xt value. So the yt value is minimum when x equals the xt value, or the y is minimum when x equals the xt value. The minimum value is the yt value when the x value is the xt value. That's why we say the xt and the yt value they go together. They go together. All right. So if I were to take this off, show you now, I can just do the D down here instead. Let's do it down here. Just answer the question. You don't have to work it out, I just did that as like a proof so you can believe it. show it to you. Right? So I'm going to answer part D now. And we know it's a minimum. So we're going to say the minimum. It's a minimum. So we're going to say the minimum value of y. And instead of saying y, I could have said the function. The function is y. Minimum value of the function, which is y, is the yt value. And that yt value is -1. So the minimum value is -1, which occurs, this minimum value of -1 occurs, which occurs, it occurs when the x value is equal to the xt value. When the x value is the xt value, what is that xt value? That xt value is 1 when the x equals 1. So the function is as a minimum value of yt, which is -1, which occurs when the x value is xt, which is 1. That's what this question is asking us, part D. What is the minimum value? And what is the value of x for which it is minimum?
So shall I write this every time, sir?
No man. You just write the values. So for example, you just say minimum value is -1 when x equals 1. Done. I'm just writing it out now for you to understand it, for you to see it. When we start doing exam papers, you see how we can abbreviate the answer and just give them the answer that they want. You don't have to write an epistle to get the answers. 6, you just want to see that you write down the correct thing, generally speaking. Right? It's only when they go and say explain something. Most times they just want to write down something and write down the answer. But we're gonna do a pass. I'm gonna look at a past paper question today and show you. In fact, all the questions are past paper. I'm gonna answer them like I would in an exam, so you can see. But I'm just explaining, writing it out now, just for explanation purposes. Instead of just write down this, I'm writing it out so you can see what is happening and understand what is happening. All right. But the next thing we want to do now is part E, which is to sketch the graph. We need to sketch the graph now. All right. So look how we're gonna sketch the graph. Let's do the sketch down here. We're gonna do the sketch down here. Now to sketch a graph, we need to know the critical information. All right? Now we can go step by step. Let's put it in blue. But the first thing was that the A, which is equal to 2, is positive. So we know that we have a smile-shaped graph. The graph is gonna go like so. We know that. The next thing we know is the C value. The C is equal to 1, and the y-intercept is the point 0C, which is 0C, which therefore is 0, 1. 0, 1. I remember we'll get all of this so far from the standard form. Standard form gives us the A and the C. So that is from the standard form in the function. And then now, the next thing we know, on the vertex form, we know that it's a minimum. So because it smiles, we know it's a minimum, right? So we know that the minimum point is xt, yt, which happens to be 1, -1. And that's how we need to sketch it right now. We don't need anything more right now to sketch it. We're not getting into the roots yet. We'll get into the roots next week. We're sketching the function with that information. The fact that it smiles, where it turns, and we intersect the y-axis. And this is where it turns. It turns at this point. That's where it turns. And this is where it crosses the y-axis. This y-axis intercept. Right? So we can just write we have it here, stick the y-intercept. Y-intercept. That's all we need for now, those two things. And it's a sketch, so we're not going to put any scale on in the graph, it's just a sketch. You don't have to be very accurate in terms of coordinates and these things. It's just a sketch. All right, just a sketch. Let me copy this down to the top of the page. Let me just move it down. The top of the page. Top of the next page. Let's move it down. All right, leave it. Let's move it down. All right. Yeah, let's leave it there. So that's what we need for the sketch. So I'm going to put in my y-axis here. I'm putting my x-axis there. It's just a sketch. Y-axis. X-axis. That's a sketch. But the first thing I'm going to say to myself, let's draw it in purple. I know that it smiles. That's what I know from here, that it smiles. Will it turn here? Or will it turn here? Or will it turn here? Where does it turn? That's the first thing I'm asking myself, where does it turn? It turns up this point. Where would that point be? Will it be here, 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 or there? Where would that point be?
Bottom right, sir.
Bottom right, because it turns where the x value is positive and the y value is negative. Positive x value and a negative y value puts us down here, similar to the one that we did yesterday. The next question is, where does it cross the y-axis? Right? We know it turned down here, so we know that. Next question is, where would this point be where it crosses the y-axis? Crosses the y-axis up here, 0, 1 is up there, or would 0, 1 be down here? Or would 0, 1 be here? Here would be the point 0, 0, you know, when there's no c, when the c value is 0. So we can make it draw a path through the origin, because this is a point, 0, 1. Where would this point be on the y-axis? Would it be up here, or would it be down here? Top or bottom? Which one? But can tell me, where would the point
Up, sir.
0? Yeah, because y values are positive up here. Y values are negative down here, right? So 0, 1 must be somewhere up here. Positive y value, somewhere up here. So we want a curve that smiles, turns down here, and crosses somewhere up there. So just draw that. Just draw it. Use your freehand and draw it like this. Done. I can move the y-axis a little bit down, the x-axis, sorry. Let's move it a little bit down, so, you know, and let's move the y-axis a little bit more over to the right. Make it a little bit more friendly to look at. So let's go like so. Y-axis, x-axis. And as I said, we have worked out that we need to turn down here and cross up here. So let's draw that. Bam. And it smiles. It's a sketch, it doesn't have to be accurate. Somebody's gonna draw it a little bit more narrow like that, don't matter. Someone's gonna draw it lean like that. No, don't make it look like a V, it smile. Somebody will draw it wide. Somebody will draw it narrow. It doesn't matter, it's just a sketch. I'm drawing this way this time. Any one of those will work. But it's how you label it now that is important. So I'm going to label this point down here, right at the bottom down here as my minimum point. That point has the coordinates 1, -1. See? Minimum point, 1, -1. And then this point up here, it crosses the y-axis. My y-axis intercept has this coordinates. Those coordinates, 0, 1. So I'm marking it 0, 1. My y-axis intercept. And then I'm just going to say sketch of y equals 2x squared minus 4x. Try that better. Minus 4x plus 1. That's a sketch of it. Right, let's move this over. We want to put in the axis of symmetry. Let's move this over here. Move it down here. That's smaller. So it can fit. All right. I'm going to put in my axis of symmetry now in red. I'm going to draw my axis of symmetry. The axis of symmetry must pass through the turning point. Don't draw it yourself, no, guys. Wrong. Everything important. Don't draw it yourself. Wrong. It must, absolutely must pass through this point, the turning point. All right. So you draw it passing through the turning point and then vertical like the y-axis, like so. It's not to scale, but you get the picture. I'm drawing to my free hand. That's my axis of symmetry. This is my axis of symmetry. And the equation of this axis of symmetry is x equals this and draw it a little bit lower. It is x equals whatever the x value is here. X equals 1. That's the axis of symmetry. Passing right through the turning point. That's my graph. And how it is, as I said, that the distance on this side is equidistance on that side. All right? Such that, for example, these two roots, which we're not finding today, this root and this root, is the same distance from the axis. Same distance from the axis of symmetry, because that's a line of symmetry. It divides the graph into two equal halves. Right? So this half over here is a mirror image of this half over here about this line of symmetry. Like a mirror line right in between there. But I understand what a line of symmetry is. That's my sketch. Obviously.
Good, sir.
Very good. What have any question? What all right?
Yes, sir.
So far, so good.
All right then. So let's see a frown one, right? More maths equals better maths every time. So let's do a frown one now. See how it works. And it frowns. All right, that's what we'll look at next. What happens when it frowns? It's the same approach, really, just different values. We just have to remember that when the A negative, it frowns. Instead of smile, it will frown. All right, so let's do the frown one now, which is this one. And I call it f of x. We can call it y just the same. It doesn't really matter. But there's f of x or y right there. It doesn't matter. Don't make a difference. All right. Well, let's work it up here now. So we're doing that one. All right. So we're gonna call it f of x as they did. We're gonna say, all right, f of x equals 8 minus 9x minus 3x squared. And I want us to complete the square. And they might write again a into x plus h squared plus k. That's what they write most times. Although sometimes they write a into x plus b squared plus c. Sometimes they even write a into x minus h squared plus k. And sometimes they might even write a into x plus p squared plus q. So write this in one of these formats. They give all those different. Sometimes they even give other stuff as well. But as I said, because they keep changing what they give, I would want to get mixed up in the exam, get confused. We're going to stick to one standard thing. So we're going to write it as f of x equals a into x minus x at the turning point squared plus y at the turning point. So whether they give me a into x plus h squared plus k, and they put a plus in here, I am still putting a minus there. You have to remember it's minus x minus xt. Based on our method, it has to be x minus xt. All right, has to be x minus xt. Pay attention to the details, everything important. Can't put no plus there, so if you're using this method, everything important, x minus xt, because we are using xt as the x value at the turning point. And the formula and the calculation that we use, you must have a minus there. It will work out itself. If it is supposed to become a plus, it will work out itself to become a plus in the end. Because if xt comes out to be negative, for example, if xt comes out to be negative 3, negative 3. Then when you put in the negative 3 and you write a into x minus, and you put the negative 3 for the xt right there, the minus minus here becomes a plus. So it's going to become a plus, it will work out itself. All right, just remember to start, you have to start by saying x minus xt. And then there's a square and the plus the yt. Now we know that to calculate this xt and this yt, we need the coefficients of the a, the b, and the c, and we have to write down the coefficients properly. Don't give it away. So we're going to say the xt that we're calculating here, formula for it is negative b divided by 2a every time. Some teachers teach with the plus h and then write b over 2a. If a teacher with the plus h, it's going to be b over 2a. But in that case, it has to be a plus h in there. So some students might come and say, oh, my teacher give me b over 2a for h. No, because the teacher is teaching with a plus h in there. I'm teaching with a minus xt. So it has to be minus b over 2a. All right, so note the difference just in case that happens. All right, I know how some other teachers do it. All right, that's xt. So I need the a and the b from the standard form up here.
Square a is negative 3.
Beautiful, beautiful. I like that. So the a is negative 3. You know, plenty of people go and put the a equals 8, you know, which is wrong, you know, because they say the 8 comes first. But a is not what comes first. It's not what comes first. A is the coefficient of the x squared term. That is a. Don't mind from the x squared term, wherever it exists or wherever it appears in the expression. The a is the number in front of the x squared. All right. So actually, the a is negative 3, as he said. Beautiful. And then the b now. The b is the number in front of the x.
Negative 9, sir.
And you have to put the negative. Beautiful. So the b is negative 9. Lovely. So the b is actually negative 9. And then the c now is the constant term, which is just 8. Which is 8. All right, we're going to put in the values now. Bam. Ready. So this becomes minus. That's this minus is this minus. Now we'll put it on the b now, where the b actually is negative 9. So it's minus and negative 9. Minus negative 9. All right, so minus and a negative 9. You can leave it like that, or you can put a bracket on it. It doesn't matter. Minus is a plus anyway. And we're dividing this now by 2a. 2 times the a value, and the a value is negative 3. Negative 3. So far, so good?
Yes, sir.
So far, so good?
Yes.
And this becomes a positive 9 over a 6, right? A negative 6. Right?
Yes.
That's 2 times 3, 6, right? We want to simplify that down. We want to simplify it. So it really becomes, right? It really becomes negative 3 over 2. It really works out to negative 3 over 2, negative 1.5. If you were to divide 6 by 9, 9 by 6, you're going to get 1.5, which is that. And then it's negative. So this negative under here renders the final result negative. So that is negative 3 over 2. We tend to always try to simplify. So it means that all of this negative 3 over 2 is coming right here where the xt is. So you're going to end up becoming a plus in the bracket, you know, minus times minus is going to give us a plus. We're going to see it shortly. But that is the xt value for now, negative 3 over 2. And then the yt value now is 4ac minus b squared divided by 4a. You just have to remember the formula, guys, for this topic. Not going to be on the formula sheet. You have to know it in your head. This method. All right, let's put in the values carefully now. 4 times the a value. The a value is negative 3. Negative 3 times the c value. C value is 8. Minus, that's this minus, and it's not squaring. You're squaring the b, and the b is negative 9. You're squaring negative 9. And you're dividing that by 4 times the a value. So it's 4 times negative 3.
Sir, forgot the square above the 9, sir.
Beautiful. Somebody's paying attention. Beautiful. And notice, so I just simplify that down now, right? Let's simplify it down. So the YT becomes, okay, I work this out. Can work out all of it. You can leave it as written parts, but can work it out still. So it's 4 times 3 is 12, which is negative, and then the 12 times 8 is what?
Negative 96, sir.
Negative 96.
Yes, sir.
All right, negative 96. And then this minus comes back unchanged. It comes back as a minus. Agreed?
Sir, 80, I mean 81.
81. So this now squared becomes a 81. Negative 9 squared becomes a positive 81. And you're dividing that now by this thing. It's 12, right? 12. So that becomes a negative 12. So far, so good?
Yes, sir.
Sir.
Yes, sir.
And then negative 96 and negative 8. We could have simplified that a little bit, you know, because we can simplify it and divide 2 by 3, you know. Let's see, we can divide 2 by 3, for example. If we divide this by 3, but first the negatives cancel. But we can divide this by 3 and get negative 4. Divide this by 3 and get negative what, 32. Yeah. And then 81 divided by 3, 27, right? Divide this by 3 and get negative 27. So simplify by dividing 2 by 3. And then now, the negative 32 and the negative 27 is what? 32 and 27. What are negative? That becomes 59. So it becomes negative 59 over negative 4. And then negatives cancel. And so the YT is actually 59 over 4. And you can leave it like that. You can leave the fraction like this. You don't have to put in a decimal. You can leave the fraction like that. You don't put in a decimal. I'm going to take this YT value. I'm going to put it right there. Leave the fraction there. All right. And let's go. So it's okay for you to have fractions in these things. So this expression now becomes that f of x is equal to a, which is negative 3. But a is negative 3. Negative 3 bracket x minus xt. But xt is negative 3 over 2. All right, negative 3 over 2. This minus minus is going to become a plus. Don't forget to put the square. And then plus yt is 59 over 4. So I'm going to put plus 59 over 4. I'm going to write the minus minus here back as a plus to show you that the plus works out itself. So it becomes negative 3 into x plus 3 over 2 squared plus 59 over 4. That's f of x. So I'm done completing the square. That's it. We have to remember though that this is my yt value and this is my xt value right here. Xt. You have to remember those values because I need them for the next part of the question. All right. So now that we complete the square, we can go ahead now and answer the questions over here. Part A, B, C, and D. A, B, C, D, and E. Let's go now. So the first you are answering is A, part A. And now I'm going to just write down answers, right? I'm not going to go into try to explain again. I did it in the first part. The same explanation. Only thing that this one is a maximum called the A negative. Now let's do it this time. It says the coordinates and nature of the turning point. The coordinates is xt, yt. And the xt is negative 3 over 2, and the yt is 59 over 4. So these are that's the turning point. Right? That's your turning point. And this is a maximum turning point. So as we say, it's maximum. That's the nature. It's a maximum. Why is it maximum? Because all right, BCS for because the A, which is negative 3, is less than 0. It's negative. That is why it's a maximum. So it has a maximum value. That answers part A. Everybody understand that?
Yes, sir.
Yes, sir.
Good. We'll go to part B. Part B is asking us for the coordinates of the y-axis intercept. So the y-intercept is a point 0C, which happens to be 0, and the C value this time is what? 8. But the C value up here is 8. There. Bam. 0, 8. Simple like that. We'll go to part C. Part C is asking for the equation of axis of symmetry. The axis of symmetry is x equals the xt value. The xt value is this, negative 3 over 2. So it is x equals negative 3 over 2. But what some people do, they look in your sign to the positive 3 over 2 and then try to write that back here and get it wrong. Right? Don't do that. It is the xt value. Bam. So you know we end up with a plus negative 3 over 2 inside here. If you remember that xt value actually is negative 3 over 2. Just x equals xt value. This is the answer for that. The equation of axis of symmetry is that. That is the equation of that vertical line. Then we'll come to part D. Part D says we are to find the maximum or minimum. In this case, we know it's maximum. For this one, it's maximum. Find the maximum value of the function, and the function is f of x, and the value of x for which it is maximum. The maximum value of the function is talking about f of x. F of x. Let's write it. It's a maximum. We know it's a maximum. We already said it here. It's maximum. So we can say the maximum value of f of x is the yt value, the y value at the turning point. The maximum value is the y value at the turning point, which is 59 over 4. And when do you get to that maximum? When is f of x equal to that maximum value? It's equal to that maximum value, so we can say which this maximum value of f of x occurs, so which occurs when the x value happens to be the x value at the turning point, because the maximum value occurs at the turning point. Xt and yt go together, and that xt value is negative 3 over 2, just the same. That's why I like doing the question this way, because the part B and the part C and the part D always will have something to do with those values. Together or apart. Always have something to do.
So you can go back down, please.
Yeah, man, I'll just go up there to show you. That's it. That's the answer for part D. And then now the next part is for us to sketch a graph. Part E is for us to sketch a graph. All right, so let's go and sketch a graph over here now. I'm writing the information down here. I'm sketch a graph.
Hold on, can go back up picture. Please.
Remember, the thing is recorded, you know. You can go and look back. I actually want you to look back at it later.
Yes,
And I post the video, I want you to go back and look back at it and redo the questions and stuff.
so you can
Right.
continue, sir.
All right, so we're gonna do the sketch now. Let's do the sketch now. So we're gonna do a sketch. Now for the sketch, we need to know firstly if it's smile or frown. So I'm gonna say the A is equal to negative 3, which is negative Therefore, we have a frown shape graph, which goes like that. So the graph will have this shape. When it frowns like that, it has a maximum point. We know that. We also know the y-axis intercept. Y-intercept is a point 0.08. We worked it out already. That's a y-intercept. We get these two pieces of information from the standard form, the A and the C. And now that we know that, when we complete the square and get the vertex form, we now know that the maximum point is xt by t. That's where it is located. Xt is minus 2/2, and yt is 59/4. So this is where the maximum turning point is located. This is a turning point. It turns here. That's the point where it turns. This is where it turns. And this is where we cut the y-axis. This is a y-intercept. So it turns at this point, and that's the two information you need. You need to know that it frowns, where it intersects the y-axis, and where it turns. Those are the three things you need to sketch the graph. The shape based on the A value, where it turns, and where it cut the y-axis. You can know those three things, then you can sketch it. Right? Let's go and sketch it now then. So I'm going to put in my y-axis here. So that's sketch, no scale needed. X-axis here. Let's put a little more to the right. It's just a sketch, not a scale. X-axis, y-axis. All right, ready now. So first thing we know that it frowns. It's gonna frown like that. Question is, where does it turn? Turns here, turns here, turns here, or turns here. Where does it turn? Turns at this point. Which quadrant would that point be? Here, 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 or there? Where would that point be? Negative 2/2, 59/4. Where would that point be? Which quadrant?
Top left, sir.
Huh?
Left.
Which one?
Sir, the top left, sir.
Top left. That's where it will turn. Turns where the x value is negative. So x value is negative this way. And where the y value is positive. Y value is positive up here. So we know that it turns, maximum turns somewhere up there. That's what we know. So it turns somewhere up here. We know that, all right? We know that it turns somewhere up here. So it turns up here. Next question is, where it intersect the y-axis at 0.8. Where would the point 0.8 be? Would it be somewhere up here? Or would it be somewhere down here? Where would that point 0.8 be? Where would it be?
Sir.
At the top. So we know
At
that
the top, sir.
yes, we know that it intersects there. So let's need to draw a frown that turns over here and crosses up here. Any frown. That's all we need to draw now. Just draw it. Don't make it complicated. Bam. Done. And then you just label it properly. So I'm going to mark this point first, y-axis intercept, as a point 0.8. I'm going to mark this maximum point up here where it turns, highest point on the graph. I'm going to write the coordinates negative 3/2 and 59/4. That's my sketch. And I'm going to write sketch of f of x equals 8 minus 9x minus 3x squared. Sketch of that function. Then I'm going to put in my axis of symmetry since Christian spoke about it. I'm just going to draw my vertical line through here, make sure I pass through that vertex point. Bam. I'm going to label it. X equals the xt value, negative 2/2. And this is my axis of symmetry. And that's just sketch rounds. Always stay. Very good.
Sir.
All right.
Yes, sir.
Very good. All right. So we're gonna do.
Yes, sir.
Right. So we're gonna do at least one of these. But I just wanted to look at an actual exam paper before we move on and show you an actual question, an actual exam paper. Wait to see that I'm not telling any lies. All right. So there was a question on exam paper in January 2020. So you see, that is it there. There is an actual exam paper, guys. You can see. Yeah, that's an actual exam paper, January 2020, paper 2. All right, there. CSEC exam paper, very recent, January 2020. And remember, the same question that come on the January exam paper, same exact syllabus, same kinds of questions that can come on the June paper as well. It doesn't matter which one you're doing, whether it's January or June. Right? The question can be the same.
You say the paper 2 is in January, sir?
No, this is a January paper. I'm saying questions that come on a January paper, they just as well can come on a June paper. The same syllabus, same kind of question that come on January, same kind of question come on June. Not going to be the exact question, but same kind of question, because the two exams is the same syllabus. So the standard of the January exam and the standard of the June exam is the same. All right, same. I'm searching for that question now, so we can just do it on the paper itself. So this is an actual exam paper you're looking at. All right, so on here, bam. So this is section 2, told you. That's a section 2 topic I told you. So this is section 2. Okay, section 2. And part A is the equation, which we're going to do this soon. Leading to a quadratic. We're going to do a topic soon. But this is a functions question. Beating the square. And look over the right the question. They say the function f is defined as this. That's a function f of x. So I want to express f of x in this form. See, I told you, most times they give you the h and the k. Most times. Sometimes they don't give you the h and the k. But most times they give you the h and the k. And because most times they give you the h and the k, most teachers teach it with h and k. The problem is that when they change it from h and k, a lot of students get confused. And sometimes they even put a minus right there instead of a plus. If the teacher teach you with a for the plus and they give you a minus and you calculate for the plus, it's going to be wrong. The plus or minus in here makes a difference. All right, that's why we want to stick to the x, d, y, t. So we're still not going to use this in our approach. We're still going to use a into x minus xt squared plus yt. That's what we're using. All right, that's what we're using. I'm going to calculate xt and yt now. So firstly, I'm going to come in the standard form and do my a, my b, and my c. This is what I'm doing in the exam, guys. So I'm going to write my a, my b, and my c right here. So my a is equal to 4, my b is equal to -8, and my c is equal to -2. I need to calculate my xt and my yt. Move this above the space and put it up here. All right, let's move it. All right, let's move this somewhere up. And move this one now a little bit more upwards there. So we're working with that. All right. And then I'm going to calculate my xt to go here. So I'm going to say my xt is minus b over 2a, and And so it is negative minus negative 8 minus b is negative 8, so it's minus negative 8 divided by 2 times a, and a is 4. That becomes positive 8 over 8, which is 1. There's another way to calculate the YT, you know. It's easier than the formula when this is a whole number, but as I said, I'm not going to show you that just yet. I'm going to calculate the YT using the formula again, not the YT for here. So the YT is 4AC minus B squared divided by 4A. So it's 4 times the A value, which is 4, times the C value, which is negative 2, minus the negative 8B value squared divided by 4 times the A value, which is 4. We can work this down. Can work that kind of run out of space, but it doesn't matter. Let's work it down. So this becomes, let's write it like this, becomes 16 times negative 2. That's what this is, 4 for 16. And this is minus, this is now 8 times 8, which becomes
64, sir.
54, but 16 times 4, right? 16 times 4 divided by 16. This is 16 times 4, don't it? This 16 times 4 is 64. That's the same, right? I'm just writing it in terms of 16, so I can cancel the 16.
Yes, sir.
Right. And then the 16s cancel. Just to simplify it quickly, this 16 cancels, those two are cancelled by this one. And so the answer then is negative 2 and negative 4, which is negative 6. It works out to be negative 6. So this comes out to be negative 6. So that is YT. That's my YT. And now that I know that, it means that this function, I can now write it on this line. It becomes f of x equals, and I'm actually writing this one, not that. I'm correct that. I'm actually writing this. Right? Extend YT. Right, this thing. Right? It becomes a, which is a 4, into x minus xt, which is 1. Don't forget the square, plus yt, and yt is negative 6 minus 6. This is my answer. Three marks for that. See there, you ask me the question, it says state the minimum value. Just state it. Well, what is that? 1 mark, just state it. So I don't have to write any reason, and I just state it. Minimum value is negative 6. I can just write negative 6 on this line. I get my marks. Minimum value is a YT value. But when I'm doing the class, I say the minimum value is the YT value, which is negative 6. Because I'm doing the class, I want to explain. But in the exam, I know that the minimum value is YT, but I can just write this down. The sense is state. State means write down. Let's write down negative 6. Is the answer. That's still gonna write minimum value is YT value, which is negative 6. That's why this negative 6 is my answer. Next one says, determine the equation of axis of symmetry. We know that the axis of symmetry is x equals xt value. Xt value is 1. So the answer is x equals 1. That's my answer. 1 mark for that. That's an exam question on quadratics computing the square. That's an example. Okay, a different question you can see. That's it. That's an exam question, obviously. Yeah. I will stay. Very good. So see this one don't go the full. This one don't go the full ship and ask for sketch no graph, but some of them do. Some of them give you more than just this. So we still have to be able to do all the things. But this is just a typical question. This was 2020. Completing a square question in 2020. And those are the things that they ask. Simple as that. All right. But let's jump to these questions now and do a couple of these before the class is over. All right. Let's do a couple of these before the class is over. These down here. All right. Let's do one or two of those before the class is over. All right. So I'm going to go and get the homework. Let's go. Let's get it from here. The homework sheet, homework page. Now what I might have to do, I might have to float it. All right. All right, let me close this out and bring that up and bring up another screen. All right, bear with me a bit, bear with me a bit. Let me do this. Do this and do that. I'm going to do this first question. This question that we're doing on the screen, this one. We're doing this one. That's actually an exam question from June 2009, question 9. So it's actually a past question from June 2009, question 9. All right, so let's do that one. And it's a part B, C, and D. And the first part wants us to express this in that AH and K. That's the first part. In other words, complete the square. I'll notice that down here, they call the same function, call it Y. Because they call it Y, I'm just going to call it Y from the beginning. So I'm going to say from the beginning up here. I'm going to say, mute your mic, please. I'm going to say let Y be equal to 2x squared minus 3x plus 1. When I complete the square, I'm going to use Y equals A into X minus XT squared plus YT, even though they gave me A, H, and K. And that's because they're inconsistent, because this year they give that one, they give me A, B, and C. As I said, another time, they give me P and Q. And every time you look at a paper, you see, they give you something different. So we want to remain consistent with our approach. So we don't care the expression that they tell. We just know that they want us to complete the square. So we're doing it in one standard way, one set way. All right. So the XT that we want to go here, same formula, is minus B divided by 2A. So we need the A and the B. We get it from a standard form. We get the A and the B from a standard form up here. The A is equal to 2. And the B is the coefficient of X right there, which is -3. We can put the C right here. The C is a constant term, which is 1. So the A, the B, and the C. We're using those values inside here to calculate XT and also for the YT. So this becomes minus, that's this minus. Put that one first. But the B itself is -3. There's minus a -3. So that's going to become a plus. I divide that now by 2 times A, but the A value is actually 2. So that is 2 times 2. Minus is a plus, it becomes a +3 over 2 times 2 is 4. Notice I'm leaving it as a fraction. I'm not going to put that at the sum. Leave it as a fraction. Get comfortable with leaving these expressions as fractions and put it back in the answer just to say. So the X is 3 over 4. So this 3 over 4 is going to come right here. Good and easy. I now need to calculate my YT value, y about a turning point. So I can say, and my YT value is 4AC minus B squared divided by 4A, using the formula method, which is equal to, carefully substitute these values now inside here. Carefully substitute them. All right. You have to be careful with the negative signs in particular. So it becomes 4 times the A value. The A value is 2. A value is 2 right there. Times the C value. The C value is 1. C value is 1. Minus, that minus is this one. We have to square the B. You have to square the B. So you're squaring the negative 3. And you're dividing that now by 4 times the A value. Again, the A value is 2. And then we're working this down. And so the YT value really becomes 4 times 2 is 8 times 1 is still 8. This minus comes back unchanged because it is not squaring. It stays as a minus. But this negative 3 squared becomes a 9. Becomes a 9. So I'm going to put a 9 right there. And dividing that by 4 times 2 right there is 8. So this is in essence, work out the 8 minus 9 is negative 1 divided by 8. That's my YT value. So it means that the negative 1 over 8 is going to replace the plus YT. The plus YT is negative 1 over 8. I'm going to replace the plus YT with negative 1 over 8. All right. So this now becomes y equals the A, which is 2. The A is 2. So it's 2 bracket x minus xt. Xt is 2 over 4. 2 over 4. Don't forget to put the square. Write the minus part of better.
Sir, minus.
Huh?
So I saying minus negative 1 over 8.
Yeah, man. Yeah, man. Minus 1 over 8. That's going to become now. And the plus YT, as I said, is minus 1 over 8. So it's minus 1 over 8. And that's the answer right there for the first part. This is the answer for this part, you know, for B, you know. This is the answer right here. Answer for B. Then C now, right here, we clear it off. Doing C now, this one. C says using our answer from B above or otherwise. We want us to calculate the minimum value, which is really the YT value. And the question says, or otherwise, meaning it can be done another way. Why do it another way? We cannot do it from what we have. And I want us to calculate the value of X for which it is minimum, for which minimum occurs. So they're asking for the X. This one is asking us for the YT. This one is asking us for the XT. It's a matter of writing down those two values. But we're going to write total statements for the purpose of the class. So we're doing now B. Now we're doing C, part 1. C part 1 right here. Minimum value. The minimum value is the YT value. I'll call it Y, which is negative 1 over 8. Part 2 is asking us for the value of X for which it is minimum. The value of X for which the minimum occurs. Here, the minimum value occurs this minimum value occurs when the X is equal to the XT value, which is 3 over 4. 3 over 4. So the answer for this part is negative 1 over 8. And the answer for this part is 3 over 4. Negative 1 over 8, not showing so well. Negative 1 over 8. Those are the answers. And then down here now wants us to sketch a graph. And this part is asking us the values of x was the graph on the x-axis. We're going to leave out this out on that yet. Those are the rules. We're not dealing with this yet. I'm going to leave out this part for now. We're going to sketch a graph. Sketch a graph, I must show clearly the minimum point and the y-axis intercept. The y-intercept. All right, so I have to sketch a graph. So I'm going to do the sketching part D. I'm going to do a sketch of y equals 2x squared minus 3x plus 1. Right? Now what do we need for that sketch? Let's try an important thing. First thing is that the a equals 2 is positive. So it's going to smile. It's going to be a smile shape graph. And when it smiles, it has a, no, sorry, I draw from. When it smiles, it has a minimum point. Then we also need a y-intercept. Y-intercept is a point 0, C, which in this case is 0. What is the C value? C value is 1, 0, 1. So it crosses the y-axis at 1. And then we get this on the standard form. And then after we complete the square and get this form, we now know the minimum point. So the minimum point is a point xt, yt, which have the xt value and yt value. Xt value is 2 over 4, yt value is negative 1 over 8. So let me here, xt value is 2 over 4, and yt value is negative 1 over 8. That's all you need to do to sketch. That's all you need to do to sketch. All right, let me shift this down. Let me shift this further down here. So we can push it up and do the sketch. Right there. Now we're gonna do the sketch, guys. I'm gonna do the sketch. I'm gonna put in my y-axis and my x-axis. Y-axis, x-axis. This is a sketch, don't have to be accurate, don't need any scale, nothing like that. Just a sketch of it. All right. Let's draw the y-axis. Let's leave it. I'm gonna draw the graph in purple. The same thing again. We know it's a smile. Same procedure every time. We know it's smile. Where does it turn? Here, 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 or there. Where would this
Bottom right.
Bottom right.
bottom right? Where the x value is positive and the y value is negative. X value is positive over here. Y value is negative down there. So it turns down here. So we know it turns down there. Turns somewhere down here. Next question, where does it cut the y-axis? Somewhere up here or somewhere down here. It cuts the y-axis at that point. That point will be
Bottom.
so it becomes very easy. You need that smile that turns down here and crosses up there. So you do, just draw that. Just draw a smile that turns where you want it to turn and crosses somewhere at the top. So just do like this. Bam. Good and easy. Then what you do after that? Label it properly. So I'm going to mark the minimum point down here, right down at the bottom, lowest point on the graph. I'm going to write the coordinates there. 3 over 4, negative 1 over 8. It's not to scale. Doesn't matter, it's just a sketch. And I'm going to mark this point where it intersects the y-axis, exactly there where it intersects the y-axis. That point is a point 0, 1. That's what the question wants us to show. Y-axis intercept, and also wants us to show the turning point. That's it. And I just write sketch of y equals 2x squared minus 3x plus 1. If they wanted the axis of symmetry, I would go like this, because some questions would say show the axis of symmetry, you know. I would draw it like this. vertical line. I'm going to label it axis of symmetry, and it is x equals whatever the xt value is down here, 3/4. And this line continues all the way up, to the graph, like that. But that is it. One sketch. Always stay. Looking good?
Good, sir. Yes, sir.
Looking
Yes,
good. All right. So y'all know that more maths equals better maths, right? So we're gonna do more, at least one more, because more maths equals better maths every time. So let me see if there's any there that is asking us a number of things. So the second one gives us some other values, but it gives us A, B, and C. All right. It asks us for the minimum value of the function, about that same thing it's asking us. It's asking us for a sketch. It's another year now. Another year, but see, different values, but asking the same things. Let's look at this one. Same thing again. H and K. And ask us to state whether it's the maximum or minimum. Clearly, it's going to be a minimum because the A is positive. And they want us to write down the point. It's going to be a minimum, as I said, which is the xt and yt value. So this one down here is another example. But I give A, B, and C. A, B, and C. Right there. These are the values. Which is the same. I'm looking for a frown one. All right, so a frown name. We're gonna do that one. And this one give it A, B, and C. And C give it that way. Let's do this one. I don't know after that a lot of things after, but let's do this one. This one we know. A frown one. More maths equals better maths. Let's do that one. All right. That approach is the same. Approach is the same. So this question says, given this function, realize it's going to be a frown because the x squared term is here and the coefficient is negative. We know it's going to be a frown. Right. It's going to be a frown. I want us to derive the function in this format. Now, you know, just put the constant in front and then put the bracketed term second. But this is a perfect square. You know that they wanted to complete the square. So even though they gave us this, I'm still gonna go and use xt and yt. I don't want to go in the exam and change your method and change your approach and run into the problem. Do the same every time when you can. All right? So ready now. I'm in the exam room doing this question. I'm gonna say, all right, f of x equals x plus 3. Better. X plus 3 minus 2x squared. I can just write down my A, B, and C if I'm no. I know I'm gonna need. I must write them no problem. No, I'm gonna waste of time. I know that my A is equal to what? That's my A value.
Negative 2.
Negative 2. A is negative 2. The coefficient of the x squared is that. All right. My B is what?
1.
Beautiful. No, 1. See the B here, the x here.
Yeah.
In front of the x. That's where the x is. There's an imaginary 1 in front of it. So the B equals 1. Very good. Make a mistake, learn from it. And then the C, let's try to see out here. C equals what?
3.
Constant value. Beautiful. C equals 3. Remember, if you don't get the A and the B and the C right, you're gonna get the rest of it wrong. So you have to get the first part right. Everything important. So you have to look carefully. So when they rearrange it, especially when they rearrange it, and they don't put it in the standard form, the standard order that we used to, you have to be careful. The A is the number in front of the x squared. I cannot ignore the negative sign. The B is the number in front of the x. This time there's no number in front of the x, but you know there's a hidden one there. And then now the C is a constant term in the expression right here. The C. All right. When we complete the square, so even though they gave me this, I don't care about that. I'm not going to change my method. I'm going to do it the same way in my exam room. So I'm going to write f of x equals a into x minus xt squared plus yt. I don't care. When I'm finished, I can set it out like this if I want. But I'm doing it the way that I'm used to. So I don't have to be figuring out stuff in exam. Exam is the worst place to go and try to experiment and try to do something different when you don't have to. All right. So the xt value that I need for here is minus b divided by 2a, which is minus, and the b this time is just 1. It's minus 1 this time, divided by 2 times a, and the a is negative 2. So it's 2 times negative 2. It's become negative 1 over negative 4. And I'm going to leave it like that. The negatives cancel each other, guys. You don't bother leave it negative 1 over negative 4. That becomes simplified, becomes 1 over 4. So 1 over 4 is coming right here. So we have the xt value already. And then the yt value now is 4ac minus b squared divided by 4a. Putting the values carefully, especially with negative signs. So it becomes 4 times the a value, which is negative 2, times the c value, which is 3, minus a squared the b. So it's minus 1 squared. And the b is just 1. Divided by 4 times a. A is negative 2. Work it down now. Carefully work it down. So yt, therefore, this is 8 times 3 is 12. That's negative. 8 times 3 is 24. That's negative 24. This minus comes back as a minus. And a 1
Minus
squared
1 squared.
board divided by, and this is now negative 8. So the numerator works out to negative 21, negative 25 over negative 8. Again, the negatives cancel. So this is really then just 25 over 8. But I put negative 25 over negative 8. It's 25 over 8. The negatives cancel. I always simplify down to lowest terms. Now that I know my xt and my yt, I can now write this. So my f of x becomes a, which is negative 2. I'm going to put a negative 2 for the a, into x minus xt is 1 over 4. So I'm putting 1 over 4. Don't forget to put the square. And then my plus yt is 25 over
25
8.
over each.
That's plus 25 over 8. That's it, you know. But if I want to set it all like this, what they gave us, notice the squared expression comes second and the constant comes to the front. I just have to write this first, no matter. So I can just write this and say, i.e., that is, write it like how they asked me. That is f of x equals, I'm not transposing, and I'm not carrying over the equal sign, you know. I'm not changing the sign of it. It is positive. I'm just shifting it around in the expression. Just like saying 2 plus 3 is the same as 3 plus 2. Right? Just switch them around. Just shifting them around. So it becomes 25 over 8. And then I put the second minus 2 bracket x minus 1 over 4 squared. And so it is now in this format. A constant in front here. Constant in front. Then a plus a value. And then a square term. A square term. So I've set it out how I want it. That's it. So this is my answer. If I write it in that their format that they wanted it. That's my answer. Written in the format that they wanted. That's it. That's our part 1. All right. In part 2 now. This is part 1 we just did. Part 1. And in part 2, easy stuff. They want us to determine the value of x for which the maximum of f of x occurs. They want the value of x, you know. So the maximum occurs when f of x is equal to xt. So the answer for this one is just xt. This is asking us for xt. Then asking for state the maximum value. The maximum value is a yt value. Those are answers. I can just write xt here, so I just write the value, which is what again, quarter. And for part 3, I can just write the yt, which is 25/8. Those are my answers. But for the purpose of the class, let's put a little bit more sugar on it. Right? So we can say the maximum value occurs when the x value is equal to the x value, which is a quarter. And then part D now we say the maximum value of f of x is that y about the turning point, which is 25/8. Now suppose they ask us for the axis of symmetry. Let's put in some additional stuff now. Put it in blue. They never ask what to put it in. Suppose they wanted the y-axis intercept. We'll write it. Y-axis intercept is 0 C point, which is 0. What's the C value again? C value is 3, right? 3 here. So it crosses the y-axis at 3. They wanted that. Part 5, they wanted some more. They wanted the axis of symmetry. Axis of symmetry is, and that's the equation. The equation of the axis of symmetry is x equals the xt value. That is, i.e., x equals, as xt value again, a quarter, right? A quarter. Yes, a quarter. Quarter. 1/4. This is the equation of axis of symmetry. And suppose there's another part. We don't want it a sketch. Sketch of f of x. Suppose I wanted a sketch of f of x. I would have to look at the a to see that because the a is -2, which is less than 0 or negative. The graph has a frown shape. When it has a frown shape, it will have a maximum point. We already know this means less than 0. We already know that the y-intercept is a point 0, 0 C, which we just said is a point 0.03. I'll get these from the standard form. And then from the vertex form and turning point form, we know that the maximum point has coordinates xt, yt, which is equal to the xt is a quarter, and the yt is 25/8. But go with that so far? But okay with that?
Yes, sir.
And then we're going to draw this information now. Again, let's shift it down to the edge of the page. Shift it down to the edge of the page. And let's draw it. So with that information, I'm going to make a sketch. This is a sketch. It's got to be very accurate. Let's try it in another color. So y-axis, x-axis, y-axis, x-axis. All right. So again, let's try it in red. We know that it frowns. But the question is, where does it turn? I always do the same thing. Does it turn here, 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 or here? Where would
Sir, top right, sir.
Huh?
Top right.
Top right. So over here. Positive x value and positive y value. Positive x and positive y. So when we turn somewhere over there. So no, the turning is somewhere over here. Next question is, this is the y-axis intercept. Where would that point be? Somewhere up here or somewhere down here? Where would it be?
Sir, up there.
Somewhere up here, right?
Yes.
The y-equal is positive. So let's draw a frown that turns up here and crosses somewhere up there. So just do it. It's not complicated, just do it. What you do, label it properly. This point is our maximum point. Just coordinates of quarter, 25/8. My y-axis intercept is the point 0.03. And then I can show my axis of symmetry. Show it in blue. It's my vertical line down here. To the turning point, make sure it passes to the turning point. It must be vertical like the y-axis. And this is a line, this is the axis of symmetry. And it is x equal whatever the x value at the turning point is a quarter. That's the axis of symmetry. And next week, we're gonna look at how we calculate the coordinate for this point and this point, which are called the roots. This is root 1, and this is root 2. Next week, we're gonna look at how we calculate those two values, which are the x-axis intercepts called roots. That's it, guys. That's it. Any questions?
No, sure.
Sure.
Yes,
Very
sir.
good.
Yes, sir.
Sure.
Very
Yes.
good.
Yes, sir.
All right. I believe on you. I'm gonna believe you.
Yes, sir.
Turn on back my camera now. So, we have class again. Nobody going to school, right? So I think we're gonna have class on Wednesday. Everybody come to class on Wednesday, online, because there's no face-to-face yet. No face-to-face allowed. Since no
Sir, same time, sir.
Yeah, I think it's gonna be same time, but I'll announce it. I'll announce it. I'll announce it, and you'll know whether it's 3:30, 4 o'clock. But I'm gonna find out how we can actually have some interaction, all right, between now and then, as I want to simulate a face-to-face situation as much as possible. It's very important. That's something that I really want us to do. We need to talk. We need to communicate with each other, right? And talk and clarify anything that persons are not understanding clearly. We really, 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 really desperately need to do that. All right. Cannot have a year again this year where we don't communicate, and then persons have things, and because they're shy, they don't ask in the class and stuff. So, so I'm gonna figure out a way that we can do it. Maybe have some breakout rooms and stuff. We'll figure out something by Wednesday. All right, but your homework is to firstly redo all the questions that we did today. It's the first thing. So all the examples that I put that out. The homework is to watch the video as a revision, and you are to redo the examples that I did. You're trying to do them on your own, and you using the video to help you. That's what you're supposed to do as homework, as the first thing. So you're watching the video, and the examples that we did, you're gonna try the examples by yourself. Do the example by yourself. You use the video, you pause, rewind, play, and you're doing the question. Put pen to paper. You cannot learn math by watching video. You cannot learn math by reading. You have to put pen to paper. You have to do the question. So that's what I wanted to do. I want you to use the video to help you. Use the video to help you when I post the video. Redo all examples that I did today. I think we did about at least 4 examples. Redo those questions first. Use the video to help you. Pause, rewind, and play. I'm going to send the video. I'm going to send the video in the link. When I get the video, when I get the link, I'm going to send the video in the class link. So you'll see it, just as I did for the last class. All right. So maybe an hour from now, I'll just send the video, the link for the video, and you can watch it. It's a video on Zoom, and you watch it. You have to watch it online. All right. And you use the video to help you to revise the stuff. Moving on to something new after this, guys. All right. And we need to learn and understand this in order to learn the other stuff that is to come. Master each thing as we go. You attain mastery by practicing. So I want you to watch over the video, do the questions that I did first. Then after you finish doing my questions that I did, all right, and the questions that I did, look at the screen, I did this one, and I did this one. I did those 2 in red. So it means, therefore, that you know you're going to do these for me now. The ones that are marked in blue, right? You're going to do these for me now. You're going to do this one. You're going to do this one. You're going to do this one down here. And finished up there. And that one. More maths equals better maths. More maths equals better maths. So do those as practice. When you do them, you can send me your solutions via WhatsApp, each person. Right? So you do it, you take a good picture of what you have done, you send it to me via WhatsApp. Let me look at it. When I look at it and see what you do, and I come on Wednesday, and we're going over this stuff, I will know where the mistakes are. I will know what to address. I will know where you're going wrong and know how to, bring you back online. And I know what to focus on when I'm explaining some of these things again in the next class. All right, that's it. That's how we learn. All right, so you need to be committed, guys, to do what I tell you. If you do what I tell you right through this year until we get to the exam, you will be safe to do well in this exam. I'm not trying to do this thing. This is not a trial and error thing. This is something that I've done for multiple years, many years. I know exactly what it takes to get success in this subject. And if you do what I tell you, you will get success in this subject. All right. So I'm telling you today, use the video to help you. Redo the examples that I did, the one that's on the slide, and also these 2 that are marked in red. When you finish those and you're comfortable, if you have to do the question 3-4 times to be comfortable that you can work it through by yourself, then you go and you'll find that the others that are there to be done, you can do them just the same. And I want you to do the questions right through to sketching the graph. So even if the question don't say sketch a graph, do it right through to sketch it to the level of sketching the graph. So the ones that don't say sketch a graph, still sketch a graph. Go right through and sketch a graph, everything, to the full shebang. I show you the exam, actual exam question. That one didn't ask us everything, right? That one didn't ask us to sketch graph and do all of that. So we don't know which question we're getting in an exam. Some will ask you to do the full thing. Some will stop short and just ask you for a couple of things. So we need to prepare to be able to do the full thing. So I wanted to do right through and sketch a graph for me, please. All right. So by this evening, I'm supposed to be seeing some solutions coming through on my WhatsApp. So you send me some WhatsApp with your solutions. I look at them. Some of you I respond to, right? And so, okay, this is good. Whatever. I see what I can do. Let's just communicate. I'm not just a teacher that's going to teach you just during class. I'm a 24-hour teacher. I'm a teacher for the entire day, for the entire week, right through. Right? So communicate. Let us communicate. That's the best way to do well in this subject. All right. Nobody have anything that they want to say, any question they want to ask? Anybody? Everybody okay? But all right,
Yes, sir.
you're not gonna show me yourself. I need you guys, I need to see what you guys look like, you know. See, I show myself, I'm showing myself. And you're not showing me you. All right, no problem, I'll give you some time. Not gonna rush it. Right? If you notice the instructions I gave was for you to show yourself on camera, but I decided I'm not gonna pressure anybody to do that. All right, I'm not gonna pressure you to do that. But to build a connection with each other, we need to, you know, do it like we were in the classroom. We need to do this thing, even though it's online, we need to do it as if we're in the classroom. And in the classroom, I would see you and you would see me. And we would talk to each other and communicate with each other. But no, I'm not rushing it. It's early days yet. All right, you need to get comfortable with me so I can give you the best service possible. All right, guys, that's it for today. See you again on Wednesday. In fact, I expect to see messages coming through, WhatsApp messages and stuff of your solutions. Do what I tell you, guys. Do exactly what I tell you, and you'll gain success in the subject. All right, bye, guys. See you
Bye,
all
sir.
on Wednesday. Okay, then bye. Bye, Kai.
Goodbye.
All right. Bye, everybody.
Yes, bye, sir.
All right, bye-bye.